Welcome. In this lesson, we're actually going to use our trig functions to find missing sides of right triangles. So the first thing I recommend you do is you label the hypotenuse so we know if we're going to be using the hypotenuse, which we are because we know the hypotenuse's length, it's 4. We look to see which angle we have, and then we look to see which side we want. We want side BD, that's this side here. So what I'm going to try to do is use a trig function that uses this angle of 49 degrees, uses the hypotenuse, and uses this side. So if I want this side to be the adjacent side, and I can choose, I can make it the opposite or the adjacent, but if I make it the adjacent side, then I'm going to be using the cosine of that 49 degrees is equal to the length of this adjacent side, whatever it is, this BD side, over the hypotenuse, which is 4. Now I grab my calculator and I solve for that. So I take the cosine of 49, get 0.656 is equal to the length of BD over 4 times both sides by 4, and find out BD is 2.62. But it does say round to the nearest tenth, so I'm just going to type in 2.6. Again, you notice how I use that cosine ratio to figure it out. So again, first thing I do is I know my hypotenuse, so I know I'm going to be using the sine or cosine, not the tangent. And I want to find PQ. Here's PQ. I know this angle. Looks like I'll be doing the same as I did in the last one. Cosine of 49 is equal to this side length of PQ divided by the hypotenuse. So I grab my calculator and solve for the cosine of 49, which is 0.65 times by 8, and I find out my side length. So 0.65 times 8 is 5.2, rounded to the nearest tenth. Again, I'm using my hypotenuse, so I'm going to either use sine or cosine. I'm going to jump ahead to show you when I get one. Like now this one here, yes, I do not know my hypotenuse, but I'm not asked for my hypotenuse. This is the time I'm going to use my tangent because I'm looking for xy. This is xy here, and I know this side here, and I know this angle. So the tangent of 27 degrees is going to equal this unknown xy side, because that's the opposite side, because remember, tangent's opposite over hypotenuse, or sorry, opposite over adjacent. That's why I use a tangent, because we don't know the hypotenuse. Opposite over adjacent, which is 4. So now I just grab my calculator, take the tangent of 27, which is 0.5095, then I times it by 4, and I get a side length of 2. If I round to the nearest tenth, it's 2.03, so 2.0 or just 2. So again, we're using simple ratios. This ratio, I'm looking for DF, so again, I'm going to use the tangent of 27 equals this opposite unknown side over 2. Solve it just like we did the last one. Very similar in nature. So again, if you have any questions, now they're throwing in some decimals, so I'll do this one as a last one. Again, I know this side here, I'm looking for EF. EF is the hypotenuse, so I'm going to use, and I'm looking at this angle, so I'm going to use cosine again. Cosine of 23 degrees is equal to the adjacent side, which is 2.4, divided by the side length of EF, or the hypotenuse, which I don't know. This is going to take a couple steps because the EF's in the denominator. So EF is actually going to equal that 2.4 divided by whatever the cosine of 23 is. Because what I'm doing, I want to make sure everyone understands what I did here, is I multiplied both sides by EF to get it out of the denominator, because you can't have it in the denominator, so they cancel. And then I divided by the cosine. 2.4 divided by the cosine of 23 leaves just the EF on the left. Grab my calculator. Cosine of 2.4, not 2.4. Clear. 2.4 divided by the cosine of 23, and I get a side length of 2.6. 2.6. If you have any questions on how to do this, please bring them to class, but it's all a matter of setting up those ratios.